For our lab 6, example 3, we're going to use our ultrasonic sensor. It's a distance sensor that will turn on a buzzer, a piezoelectric buzzer, when it detects an object. So we're going to use this little Chinese dragon as the object, and we're going to start using our lab 6 example 2 code. So we're going to modify this to create two tasks. One's going to be to check the distance, and the other task will be used to turn on the buzzer. So let's first modify the alarm, the LED task, to make it an alarm task. So instead of task LED, let's just call it alarm. Here, instead of LED, we're gonna call it alarm. So my alarm function, it's the one that's gonna turn on the piezoelectric buzzer. So let's define, instead of LED, let's just call it buzzer. We're not using a button anymore, so we can get rid of this. Let's just define our buzzer as a pin 13. Instead of turning on to make it the pin mode LED, we're just gonna use buzzer here. We're not gonna need a toggle or a counter anymore. We're not using semaphores in this case, so we can get rid of all this. We're not using interrupts. We're not using semaphores. We're gonna use a queue, but that's gonna be later. So here we have our alarm. Make sure that it matches the name. So this was task LED. Now it needs to be alarm because that's the name that I'm giving it here. So alarm. And in my alarm function, what I want to do is to first, let's make sure that we're actually being able to turn on the piezo buzzer. So here, let's just, for now, let's just keep it to turn on the buzzer. So we're going to use the tone function from Arduino, buzzer, and here we can play a note. So there are different frequencies that will play different notes. Let's use, I think in my example, I'm using E6, which is this frequency. I'm gonna round it. So I'm gonna use an E6 note. It's the frequency for that note. So let's define it. Define E6 as the frequency of my note. And let's round it to 19. And here we're just gonna turn the buzzer as an E6 note. So that's gonna play the E6 note. Now, since we're inside of a task, we can use delay. If we try delay, it won't work. Let's give it a try, just to show you that it doesn't work. The no tone. So this will play the buzzer. We're trying to play it for 100 milliseconds and then stop it. So let's give it a try and see how it works. So at this point, we're just running that task infinitely, priority 0. So let's give it a try. Let's see if it works. And as you can see, oh, it's not responding. Let me reset it. It's not responding, so I may need to reset it. Yeah, I'm gonna have to reset it. Okay. see if it works. Good. And it's not working. It should play the buzzer. Oh, pin 13, my bad. It's connected to pin 9. So, pin 9, there you go. It kinda works, but it's not constant. So instead of that, we're gonna use, let me change it. It's really annoying. The delay that we should use here is btask delay, which is a proper delay for our functions. And let's use 20 ticks. Okay. I need to change this one to pin 9. Let's see if it works. Okay, that's better. I'm gonna change this one to 8 because it's really annoying, but we know that it works. Now, it's time to make our second task, the proximity sensor one. So let's go up to our setup, and we're gonna copy this to make it faster, because we're engineers and we're lazy, right? Instead of alarm, let's just call it proximity sensor. So it's proximity sensor. You can put the same name here. Now in my mind, I will give this one priority 1 because the most important thing is the alarm to turn on. So that's why my alarm it's getting priority 0 and my proximity sensor is getting priority number 1 here. So let's make our function, our task function here below, which is gonna be proximity sensor void PV parameters. And here inside, what I'm going to do is I want to initialize my HCSR04. So let's make a variable called data, or centimeters. This is going to record just the amount of centimeters that we're recording with the proximity sensor. So it's going to be HCSR04, which I haven't declared. So let me put it here. Let's declare that first. So first we need to include the HCSR4 library, so let's include it. HCSR04.h, that should be given by Arduino. If not, it's gonna be in Blackboard, so don't worry about it if you don't have it. Let's see. Yep. So I have included the library. Now we need to make our type sensor. So ultra sonic distance sensor. HC is our 04, which is a model of this ultrasonic sensor that we're using. 12 and 11, which are the pins that I'm using here. 12 for trigger and 11 for echo. And now going back to the visualization of that, should be here. We can just do measure distance in centimeters. So yeah, this must be given by Arduino already. You don't have to download anything, just include it. Let's now just try to see what we're reading in distance. So that data, that distance that it's being read by the sensor, it's gonna be printed in the serial console. So we need to initialize our serial console. Let's test it and see if it works. Okay. I guess it's going like crazy because it's too fast. So we should include a delay here. Let's put a small delay here. Okay, that's better. 26, 27, and then when I put the dragon next to it, it's 8, 7. If I get it closer, small starts to go down. If I move it away, it's gonna detect further distance. So we can say that it's indeed working. So, yeah. If I take it out, it's gonna do another read here, right? And I put it, and it goes down. -1 is when it's not being able to read it. So that happens when there's a problem with the connection here in my wiring. So, that's important to know. It's just the way that the library works. So now that we know that our proximity sensor works and our buzzer works, what we want to do is to turn on the buzzer when the object is detected. So if you notice here, 9 is the further I can have it. If I get it closer, it's going to 8, or let's say below 8. That's going to be my threshold. So the problem is that here we have one task that's recording the distance, right? But we want this data that it's being tracked in this task to be processed here in the buzzer section. Right now, these two tasks are being run by the operating system. So this is being run for a certain amount of time, then it's jumping here to test this, then jumping to the other one. So it's doing both instructions at the same time. Even though I have an infinite loop here, look, if I make an infinite loop here as well, that won't affect at all because since it's a FreeRTOS, it's doing both tasks simultaneously, or doing one part of another one, then moving to the other one, going back and forth. So the way that we send data between functions, if you remember the notes, is using queues, right? Which works as a mailbox. So we need to create a queue to send data between one and the other. So let's go include that part and our lab will be done. So if we want to create a queue, that's in the semaphore library, which is the one that we have here. So we're good. Now we're ready to make our queue. So queue is equal to xq create tail, which is a queue length. Just to, like if it were saving two variables, but we're just saving one. Then what type of, so it's gonna be two sides of int because we want to save variables, and that's it. So we have created a queue to save data. Now that queue, which works like a mailbox, can save data, and we can put data, and then the other function can take out that data. So if we go here, once we read the distance in centimeters, we can send it to the queue. So it's xq send. We're gonna send that data to the queue, which is like a mailbox, right? Queue, which is the name that we gave it, queue, and we're attaching to that queue our data, which is this one. So we need to make a pointer to the data, or put the address of the data into memory, and we're gonna use a 100, which is a the time that we're using for that data to be sent. So when we send it, the next function can now take that data. So in our function, in our buzzer first, we're gonna check if there's something in the queue. So let's do xq receive our queue and mail equal to 100. So mail, it's just a variable that's saving my data that it's been saved from my queue. So let's just make it here in mail. Notice that I'm using int format because I declare my queue to be saving integers. So I make my mail, right? I check my queue. If I'm receiving anything and I can open it, it's gonna be saved into mail. So when this is true, I'm gonna get a PD pass. That means that I'm indeed receiving some data. So in the case that I check my queue and I receive data, that means that this task right here has been able to measure distance and send it to the queue. So in my queue, I receive that data, I save it into mail. A PD pass means that I indeed received it. So now let's check my mail. If mail, that remember mail, it's the data that I'm receiving, which is a distance in centimeters. So if my mail it's below 8, right, which is what we get when we get this one close. If I remove it, it goes above 8. It's at 8, but if I put it closer, it goes to 6 or below 8. So if my mail it's below 8, let's play the buzzer. Otherwise, let's just not play the buzzer. It's a no tone. And that's it. Now I'm checking if the distance sensor, which is sent from this function, from this task, it's below 8. That means that there's an object. So I'm gonna turn on the buzzer. But since this one is running constantly, infinitely, in parallel, when I remove the object, data it's gonna be equal to, in this case, I don't know, 25, 26. That's gonna be sent to the queue. Then the code is gonna jump from here to here because that's how it works. It works between these two tasks. It's gonna check the queue, check the mail. If I receive anything and that's below 8, it's gonna turn on the buzzer. If it's over 8 or at least 8, it's just gonna stop playing the buzzer. Let's give it a try. And was not declaring the scope. Did I forget to declare my queue? Oh yeah, sorry, my bad. So queue handle underscore t queue. Good. Okay. And let me change this one tonight because it's the one that I have in my schematic here. It's the one that I have connected here. Okay. So right there is not detecting anything. Let's put this one closer. And it's buzzing. I remove it. And it stops playing. I put it here. And it's working. And that's how your lab 6 example 3 should work.